So here we will try to solve the following differential equation using the Fourier transformation. Okay. So our differential equation is the following: second derivative of u plus alpha squared times u of t is equal to h of t. Okay. So t is a real number, and h is an absolute integrable and continuous function. Okay. So here we can recall the following rules for the Fourier transformation of the derivative of a function. So if you only have one variable, so you can only take the derivative with respect to one variable. Basically, you get just j omega times your times the Fourier transformation of your function. Okay. If you take the second derivative, we will get j omega squared times the Fourier transformation of your function. J is the imaginary number. So it's the square root of -1. I use j, you can use I if you want. Okay? And so that will be equal to minus omega squared times u hat. Okay? So we can apply that to our equation. Okay? And so we'll get minus omega squared u hat plus alpha squared times u hat, okay, is equal to h hat. Okay. So we get omega squared u hat plus alpha squared u hat is equal to h hat. Okay. So we'll get that u hat is equal to h hat times 1 over omega squared plus alpha squared. Okay. Now we can use the we can take the inverse Fourier transform of both sides. So we'll get that u is equal to the inverse Fourier transform of h hat times the inverse Fourier transform of 1 over omega squared plus alpha squared. Okay? And now we can use the convolution theorem, which says that the product of the inverse Fourier transforms of two functions, okay, is just equal to the convolution of those two functions. The convolution is defined as the integral from -infinity to infinity of f of tau times j of t minus tau d tau. Okay. So if we do that, we get that u is equal to h convoluted with I just see that I made a mistake. The convolution theorem doesn't state what I said. It states that let me just rewrite that. It states that the inverse Fourier transform of the product of two functions is equal to the inverse Fourier transform of one function convoluted with the inverse Fourier transform of the other function. Okay, it states that. And so we will get that u is equal to h convoluted with the inverse Fourier transform of 1 over omega squared plus alpha squared, okay? And that will be our solution, okay? You can try to find the inverse Fourier transform of 1 over omega squared plus alpha squared, but I will let it just that way, okay? It should be correct. So yeah, everything you need to know is you need to know how to apply the Fourier transform of the derivative of a function, okay? So you have just j omega, which comes in front of the Fourier transform of your function, and then you can solve algebraically and then use the inverse Fourier transformation and the convolution theorem to solve for your function. Okay? Thanks for watching.